Can you all see my screen? Hello?
Hey.
Yeah, can you see my screen?
Yes, no.
Yeah, okay. So the first question is, we have given the number which consists only 6 and 9, and we need to return the maximum number by changing at most one digit, either 6 to 9 or 9 to 6. So for example, this is 9669, and what number like we should change to get the maximum number like these, and constraint is we need to change only one digit, and the size of the numbers is from 1 to 10 raised to power 4, which is like 10,000. Yeah, and the numbers contain 6 and 9. So for example, this 9669. So if we first change the digit 9, this digit to 6, it will be 6 6. Yeah, so if we change this 9 to 6, it will be 669, which is small. Then if we change this 6, it will be 9969. And if we change the third position 6, it will be 9699. And similarly, if we change this 9 to 6, it will be 966. And which one is the biggest is 9969. So this is an answer. And if you are not able to change, like this 999 is the biggest one, just need to return that number. So any thoughts? I think this is a good question and an easy question. There are a lot of versions of this question. Let's discuss first this and then we see what. Any approach comes in your mind? Anyone?
So I believe the goal here is to find the leftmost 6 and then change it to 9.
So the goal is to give the maximum number. Yeah. So, and the maximum number, how maximum number would give, we should convert, we should check, because 9 is bigger than 6. And yeah, so we need to convert any 6 which comes first, like from the leftmost. Whenever we see a 6, you should convert to 9. Is it like that?
Yep. So I was just trying to like rephrase it. So based on the requirements, whatever is the 6 on the leftmost, okay.
Yeah.
Switch that to the 9.
Yeah. So so everybody is following this approach. So I should write it down. So for example, we have 9669. So we need to see which number we should change so that it will become a max number. So if we say change anything from the start time, it will become the max number. And whenever any 6 would come from starting from the left, that would be our answer. And we need to convert to 6 to 9, like this. And yeah, that's it, I suppose. Nothing much to do. And the complexity will be either, in the worst case, we need to traverse every digit. Like, for example, if there is no, at most we have to traverse every digit to check whether we can convert 6 to 9, or if there is a 6 ahead, 6 is there or not. So in the worst case, it would be order of n.
So what should be the approach first? Like how we can traverse the digits in a number?
So what do you guys think? Like, if I want to say I want to convert it into a string form.
Fair enough. Like that's a one approach, but if you don't want to convert it to the string, anyone has any other approach?
Yeah, anyone?
We can do mod, go from, right to left. Get mod digit by digit, right? And keep track of the okay, so let's say we mod from right to left. We mod it to 10, then first we get 9, then we skip it, and then next we get 6, and then we convert it to 9, and that would be our best solution so far, right? And then we keep moving left again, and then we see 6 again, and now we can convert it to 9, and we keep this as our best solution, and we keep doing that until we we get 0.
Just a question. Is there a way we can directly get the number at suppose second position from left?
But how we are knowing that we need to go to the second position?
I'm just saying, just a food for thought. If we know how to get second position element from left, we can always use that same logic to get first element from left. Right?
And we use math log to find how many digits in the number. Then we can travel from left to right.
What I did, I extracted all the digits, put on the stack, and then reconstruct the number again.
So, so for a stack, you did you started from the rightmost.
Yes.
And put it into the 9, 6. From the rightmost 9, then 6, then 6, and then 9, and then whichever. And when you pop it out with whichever value you got from earlier 6, you convert it.
Convert it to 9, and then.
Yeah. Okay.
Yeah, but we want to go from left to right.
Yes.
Suppose. How would we do that?
So what will happen? Hey, Sonia, if you want to write it down, just for clarification. Okay, let's say we first mod this number by 10. We get a 9.
9.
Okay, and then divide the number by 10. We get 9, 6, 6.
6, 6.
Okay, then again we repeat the same. We get another 6.
Okay, so, yes, we get 6.
Yes, so the stack contains 9 and then 6.
Yeah, stack will contain 9 and 6, correct.
Okay, from in that order. Okay, and then again we will get 6, and again we get 9.
Because now our sum is 9, 6, and now
just put all the numbers in the stack. Okay, if we are putting all the numbers in the stack, it should be the rightmost number first, then 6, and then 6, and then the leftmost number 9. So that should be our stack. Just repeating this process.
Yeah, so it would be like this.
Yeah, and just change this number, maybe have a 9 in the start. Just change this number for clarification. Have a 9 in the start. So instead of 9669, take 99669.
99669.
2 6 and then 1 9. Yeah, just cause that was palindrome, so stack was not very clear. Okay, so in this we get 966, and then on top 9.
On top 9 and 9.
Then another 9. Okay, now if we pop from this stack, we are again getting the numbers from the rightmost. Okay, which doesn't solve our problem because we need to start from the leftmost. So instead of stack, what if we just put put all those numbers in an array.
But we are getting from the leftmost. We need to convert from the leftmost only. If we are popping it out 9, 9, whatever the number we have popped, like earlier 6 we converted it to 9, and then that's it. We don't need to.
Sorry about that. Yeah, like I just like misunderstood it.
Yeah, that is still go from left to right. So, you know, like I mentioned, we can use a math log to find the number of digits for the given number. Then, given the number of digits, we can mod with 9,000, or you know, then we keep doing that until we find the first 6. So that way we can travel from left to right.
I'm not sure actually. Math.
So for example, you use a math for this number, right? You use the math log and you find that, okay, this number have 5 digits.
So math.log, you are saying something?
Yeah, I think so. Yeah, it returns us the number of digits.
Number of digits.
Yeah. So in this case, it returns us 5.
Oh, which is 5. Okay. Yes. So it will be after 5, what we should do?
Then I think it let mod it by 9,000, by what, 90,000.
This number?
Yeah. If we mod it by 90,000, right?
What does log of you know, when you do a log, what does it tell you?
So math.log.
Yeah. So if you convert it into a normal mathematical equation, what does it tell you? So 2 raised to power x, let's say we have a log of base 2.
Yes.
So it says y is equal to 2 raised to power x. And if you do a log on both sides, log of y equal to, log of y to the base 2 is equal to x, right?
Yes.
Now, if you take log to the base 10 on both sides, it essentially tells you what is the nearest 10 raised to power, which first, you know, reach to that number. So if you do this math.log to the base 10 of this number, it will give you a number, which is essentially giving you what is the nearest 10 raised to power.
Okay.
Right? Now, in this case, what will happen is it will give you 10 raised to somewhere between 10 raised to between 4 and 5 value. So you can take a floor of that, because 10 raised to 5 will be a number with 5 zeros, and 10 raised to 4 will be a number with 4 zeros.
Okay.
So what you can do is take the floor of that log, and it will tell you after the first digit how many zeros will be there. Right. So in this case, if we take the floor, it will be the math.log of this number will be floor of that will be 4, not the 5. It helps us to reach the number of digits. That's correct. But in this case, we don't require number of digits. We require number of you know, digits after the last one.
Yes.
Right. Now, can you do a 10 raised to power 4?
Okay, 10, which is raised to power 4.
And just write that value.
10 raised to power 4 is, which is 10.
1 followed by 4 zeros.
Yeah.
Right. And now if you do a division of this number, you know, division of the original number with this number, what will you get?
Which is 99669. We'll get 9969. Remainder, if we get, we want.
I'm just talking
the
about
remainder.
the
Remainder would be
division.
9.
Not the remainder. I'm talking about the quotient, integer division. Remainder is a.
Oh, okay. Yeah.
Operation.
Yeah, that would be 9, right? Yeah.
Yeah.
So
9.
your division will give you the index, which is 9. You know, what is the value of the number at that position that you're looking for. And the modulo operator will give you what is the remaining after that.
Yes.
Right. Now you have 9, which is giving you the current value. And then you do modular division, it will give you 9669, which is the remaining value. now you have that sequence created for you, how you can iterate from left to right. Now the only question remains is how do you want to reconstruct that sequence while moving from left to right? And the logic will remain same. I'll give you 2 minutes to just think about that. The way we are dividing that sequence, we can reconstruct that sequence also. Like for example, we have 99669. So initially when we do 2 steps, we'll somehow be able to traverse through 99 and then we'll reach 6. Know that there's something called 99 before and there's something 69 after.
That sounds like a reasonable approach. Anyone has any questions on this approach?
No.
So we got like
Okay, yeah. So
multiple ways.
so if I just have a curious question, it was asked in a lot of times. So if we have like you have a 4-digit number and it is in the range of 1 to 9, so what would be the maximum number? So any kind of this approach would work in that problem. Like you have a numbers 1 to 9 and it's a 4-digit numbers you need to make, and you need to make the max number out of it.
I did not get it. You need.
Give an example.
So
Can
for
you type an
example,
example?
I'm not sure it's that only. Yeah, 1 to 9 you have, and like 4-digit or 5-digit. I'm not sure. 4-digit number you need to make, and you need to make the max number.
That will be 9999.
Yeah, that's what I was like thinking, but it's kind of some kind of related questions, but I need to think about it.
I think if I understand it correctly, so you have to use the digit given in that number. So in that case, you have to
Yes.
set the digit and
Yeah.
just sort the digit in descending order and then construct the number.
Correct.
So like if we have 2, 4, 5, 6.
Yeah. So extract these digit
Okay.
and then sort them. So those will be, yeah. So if you have when you will sort it, so after sorting in your array, you will have number 2, 2, 4, 5, 6, and then construct the number from there. So your number reverse sort in reverse order. So your digit will be 6, 5, 4, 2, and then construct the number. So your number should be 6, 5, 4, 2.
Okay, so it will be like 6, 5, 4, 2, which is a max number, you're saying.
Yep.
That's an analog, and I would say.
In terms of complexity.
You can do it in O of n as well. Just maintain the count of each number. Like,
Counting sort.
yeah.
Yeah. So yeah, that would work. Okay, we should move on to the next question. Thank you so much.